right, so standard mean and standard deviation. We calculated that yesterday, right? So we got the average student in this class is about 60, almost 66 inches tall. It's about 5'6". Okay, that number varies by about 4 inches. Okay, because not every student was 65.968, right? So that's why we have standard deviation. Okay. So now what we're going to do is to check to see if these heights are normal, considered normal. Okay. So how do we do that? Well, the first thing we do is to see if 68% of the data is within a standard deviation plus or a standard deviation minus. So this is what I want you to do. I know the mean, right? I just figured out, you guys figured out the mean yesterday. It was 65 point what? 968. Okay. Now what I want you to do is I need to calculate these two values. How do I calculate that value? Okay, so what is a mean plus a standard deviation? What is that going to be? Tell me that. What is a mean plus a standard deviation going to be? Anybody get it? Let me know when you get it. 69.835. Good. Okay. Good. What about a standard deviation, or sorry, a mean minus a standard deviation? Give me that number now. 62.103. So what you guys just did was you added them together for the plus and you subtracted them for the minus, right? That's one standard deviation. This is one standard deviation, right? Okay, so now what the empirical rule says is, out of the numbers that we have in front of you, do 68% of them lie between these two numbers here? We'll go count. Go to that list. Count how many numbers are between these two guys. 62.103 and 69.835. So go actually and count how many are between those two numbers. And tell me what you come up with. How many numbers you come up with. $25. So do I include 62? Let's say someone is 62 inches tall. Do I include them in that 25? No, right? Because they're just under that. So I'm looking for everyone who's 62, 63, 64, 65, 66, 67, 68, or 69 inches tall. That's who I'm looking for, okay? Okay, so what's the number? 19. Okay, 19 now. Usually when two people get the same answer, it's usually the right answer because the probability of two people making the exact same mistake is pretty small. So that's usually how I check. How many total? Yeah, you guys have in front of you 31, right? 31 students in the class. Okay, what percent is that? 60 so let's go. So 3 places, 0.613. Always go 3 places if you can. If you can't, don't do it. Like if that number was just 0.6, we can't go it. But if you can go 3 places, always go 3 places because it'll help you later when you're trying to do other things. Okay. Okay. So This is what I actually got. This is what I needed. Okay? That number is close, but it's low, right? It's about 7% low. Okay? So is it close enough or is it too far? We'll make that judgment later. Let's just do the math right now. Okay? So we just wanted to come up with a number. So that's, like I said, that's 61.3%. That's what I came up with, right? Okay. Now we're going out one. So now we're going out one from where we were before. So the mean is still the same, right? 65.968. The mean is still the same. The average is still the same. I haven't changed the numbers. But now what I want to do is get these two guys. That's my next question. How do I come up with that guy? Yeah, it's just 2 times this plus this, right? 2 times this plus this. Well, we know what mu is. I know what sigma is, right? So 2 times sigma plus mu. That's why I wrote a 1 in front. Because if that's one of them, 2 of them is double. 3 of them is triple. 4 of them is times 4. The quicker you learn the symbols, the lot easier this class is going to be. Because we use symbols a lot. Okay. So if I add 2 standard deviations to 65.6968, what do I get? 8. That's a little high. That's a little high. Yeah, it's a little high. 73 point what? 696. Okay. Because 2 of these guys would be 8-ish, a little under 8. 2 of these guys here would be around 8. So that seems pretty close. Okay. So what about if I take away 2 of those guys from the mean? I'm going to subtract around 8. So it should be 58.240. Okay. All right. So now what I want you to do is do the same thing. Go count how many of our numbers were between 58.24 and 73.696. How many of them? So all of the numbers you counted earlier still count, but there's going to be some more. Yeah, so no, add this. So 2 of these guys. Add, yeah. Let's see. So let me write these down. So 1 standard deviation. Let's see. Let me write these down so I can. Okay. 9 what? 8, 6. Okay. So to come up with the numbers that we're working with now, you double this and then subtract them to get over here. And then you double this and subtract it and you come up, or add them, sorry, and come up with this part over here, right? Are they different? Are they wrong? Let's see. So if I double the standard deviation, I get 7.728 if I double the standard deviation. And then if I add it, 968. I get 73.696. Yeah, that one's okay. Double and subtract. Yeah, that's right. I get those. Okay, so how many do we get? How many were in between those two values? 29. So what percentage is that? 9.3. Keep going. 5.4. So just 5. So that is 93.5. What percent were we supposed to hit? That's pretty close. That's getting closer. It's getting a lot closer. Before we were off about 7-ish. Now we're off 1.5. That's closer. Okay. One last one. One last one. The big one, 99.7, almost 100%. So the mean again is 65.968. If we go out 3 standard deviations, we're going to be even farther away from the mean. So what do we get when we do that? 77.56. And then if we subtract 3 standard deviations, how? 54.376. Okay. How many are in there now? You're going to do this later on your own. You're going to do this later on your own. So if we're moving too fast, you're like, well, I can't. You're going to do it later on your own. I just want to do one together. Okay. You're going to do it with our data. Okay. So how many are in between 54.376 and 77.56? I believe it's all of them. I don't think I had anyone shorter than 54.376. I don't think I had anyone over 6.5. 1.0, 100%. This one we're even closer. We're pretty much on, right? We're pretty much on. There were no crazy outliers, crazy tall or crazy short outliers in the set of data. Okay. So that one's the closest. 95 is pretty close. This one is pretty close too. Pretty close too. Now, I want you to do this. You have the data in L1, right? You have the data in L1. That's how you got the mean and standard deviation, right? Give me a histogram. Show me a histogram. What does the histogram look of the data? So make sure your data is in L1. If it's your calculator, the data is going to be in L1 because you put it in. But if it's one from the tub, make sure the data is in L1. Give me a histogram to see what the actual data looks like, to see if we're doing all right or we're... You don't have to draw it, just look at the picture. Would you consider that normal? Would normal with a capital N, not normal like average or standard or basic, normal with a capital N. Would you consider that normal? You have pictures of what normal looks like. Would you consider it normal or would you consider it skew? What would you consider? That's what I want you to do right now. Oops. So make sure you select the right one. Make sure it's list 1. Frequency we never touch. You never touch frequency. You leave frequency the way it was from the beginning of time. And there it is right there. That's the actual data. So one way is the empirical test, which we just did. 68%, 95%, 99.7%. But we're kind of, we were like, is 61 close enough? Is this close enough? Is 61.3% close enough to 68? Some of you would say yes, some of you would say no. What's the answer? Right? 95, is this close enough? Most of you probably would say, yeah, it's close enough to 95, right? Everybody would pretty much say this is close enough, right? So how do we make a final judgment? You look at the picture. You look at the picture. Would you consider that normal distribution, or would you consider it, what shape would you consider this most likely? Okay. So the tallest two bars are on the left side, right? And then kind of drifts off after that. So maybe skew right. On the test that you guys took, there was one where about half of you put skew right and half of you put, or skew left, and half of you put, it was a similar graph to this, and some of you put symmetrical. I didn't take away credit for either one. I took away credit if you didn't back it up. If you didn't tell me why you thought it was symmetric or why you thought it was skew left. If you told me and it made sense, I gave you credit. Okay? So does this guy look like, it's not going to be perfect, but my question is, does it look like this guy right there? That's the question. If it's close, then we say approximately symmetrical or approximately normal. If it's not close, you're like, no, that looks more skew. Then it's not. Okay? Then it's not. If it looks more like this or like that, okay? That's what you do. Okay? Now, luckily, most of the stuff that we go over, they will tell you if it's normal or not. They will tell you. You will see normal. If you look at the notes I gave you today, each one of the examples, they tell you it's normal. They tell you it's normal. Okay? So most of the time, they will tell you, hey, it's normal. Okay? So you don't have to do all of this stuff. We only do this if they want us to check to see if it's normal. And then you make your best judgment. Okay? Based off of everything. So it's not necessarily the answer that I'm grading, it's your reasoning behind it. Okay, yeah, I think it's normal because 61% is pretty close to 68%, and 93.5 is pretty close to 95. And when I looked at the picture, when I looked at the graph, it looked pretty normal. Most of the data is in the middle, so it looked pretty normal. Yeah, we'll go with roughly normal. Full credit. Okay? What if someone else said this? You know what? 61 is too far away. 61 is too far away. It's close, but not close enough. This one's closer, but this one's really sticking out. This one's kind of sticking out. It's not close enough. And when I look at the picture, it backs it up because I see skew right. Full credit. Okay? Because you explained your reasoning. This will get 0 points. That's symmetrical. Yeah, that's normal. 0 points. I don't know why you chose that. Okay, I don't know why you chose that. You have to. It's your way to communicate. How you're able to communicate yourself. That's what you're graded on with these types of questions. Okay, your ability to communicate. So when you're doing that, there are more than one answer. Okay, there are more than one answer. Okay, not everything's crystal clear. It's how you communicate yourself. All right. Okay, so what I want you to do now is a couple of things. Okay, so let's do this. Here's our data. Here's our data. Okay, that's our data from yesterday. Okay. Right, Claire, what was yours? I didn't get yours. What was yours? 65. So let me add that one there. Okay. So that was our data from yesterday. Okay. So what I want you to do is do the same thing I just did. 68%. Check the 68% rule. Check the 95% rule. Check the 99.7 rule. Look at the graph to see if that matches what you think. Okay? I'll give you about 10 minutes, 15 minutes if you need it to do that. Okay? You can erase the data from the other class, from the other one. You can erase that data. We don't need it anymore. We're just going to use this stuff here. Okay? So are our heights normal? That's the question. Okay? Okay, so I calculated the number. I didn't calculate the percents, but I calculated the numbers. So one standard deviation above and below, that's in red. Or this is what I got for my mean and standard deviation. And then 2 standard deviations above and below, that's what I got. And then 3 standard deviations above and below, that's what I got. Okay. So what percentage was from 64.94 to 70.95? 55%? How many were in there? How many of you guys were in there out of 20? 21? 20. Let's see. 64. So I count 65 to 70. 65 to 70. 65. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see. 65, one more time. 65 to 70. 65 to 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? 12, okay. So there's 12. 12 out of 20 is 60%. Okay. So 60%. So this one would be 60%. A little low, just like my other class. Okay. There's not as many of you in there that then needs to be. Okay. All right. Now 61.9 something to 73.9. So 62 to 73. 62 to 73. 62 to 73. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. Is there any that don't fit? Oh, 73. I shouldn't have counted 71 and 73. Oh, sorry. I shouldn't have counted this guy, or this guy, or this guy, or this guy, or this guy. Those are too high. Oh, sorry. Sorry, looked at the wrong color. So is there anybody over this? Is there anyone over this? No. Okay. Is there anyone under this? So that's everyone, right? So 95 is a little over. We're at 100% for 95 already. So that's a little over 5%. So that means 99.7 is pretty close because it's 100%, right? Again, are those close? Is 60% too far away, or is it close enough? Is 100% too far away? Look at the picture. What do you see when you get the picture? So you look at the graph just like you did the last one, and it kind of looks like the last graph. Looks very similar to the last graph. Okay, I don't have it up here, but I have it in my calculator. So again, that one I would take, yeah, it's pretty normal. It's approximately normal because of these reasons. Okay, not just it's approximately normal. It's approximately normal because of these percentages and the picture. Here's a sketch of the picture. Or now the percentage is a little off. These percentages are off. 60% is a little too far from 68. 100 is too high compared to 95. And if I look at my picture, it looks skew right. That's reasonable. That's a reasonable answer too. Okay. because it's pretty close. It's pretty close. Okay, that's how you check normality. That's two ways. One way is the empirical rule. One way is look at the picture. That's why we use both. There's a third way that we don't teach anymore because it's not covered. There's a third way. It's on your notes, but I don't cover it because we don't need to anymore because it's not covered in the AP test. It's called it's on this paper. What is it called? It's on the last page, the normal probability plot. We don't cover that. It's another way to do it. Okay. But yeah, that's the third way. All right. Okay, so last thing we're gonna do, very last thing, and this is gonna be one of the most beneficial things all chapter you're gonna use. You're gonna keep coming back to this time and time again, trust me. Okay? So go to this page here. It's in the notes you just have. It's this one right here. I started doing this last year because students would struggle with this. And I gave them this picture and I had them label it, and it became a lot easier. So we know percentages, right? I know percentages. 68% is in that purple there, right? 95 is in the purple plus the pink. 99.7 is in all of the colors, right? So what I want you to do is convert that to this. Now I divided it up even further. Okay? So in all of these sections, we know there has to be 99.7, right? So let's look at this guy. Start with the purple. Where does the purple go from? Where is the purple? One standard deviation above, one standard deviation below. And how much is in that purple? 68%. So let's go down to our blank one. Find one standard deviation above and one standard deviation below. How many sections is it broken up into? Two. It's broken up into two instead of one, right? From here to here, and all of this in here is 68%. So I have a very important question, which you probably all know. What is in this one then? 34%. You guys would be right. Why? I agree, half of 68, but who says it's half? I agree. Half of 68 is 34. My calculator agrees with you. But how do we know it's half? Why is it half? They're both going the same distance out. That's true. What else? What's that? That's what Christian said. I agree. What else? There's another reason why. Starts with an S. It's written in your notes a couple times. Symmetrical. What do we know about things that are symmetrical? They're exactly the same in the half. If you cut them in half, some of you said, oh, from the center. Yeah, you're right. This is the center. If I cut it in half like that and fold it, it would be exactly the same. That's the reason why it has to be 34. Okay, don't tell me this is something I get. It looks the same. There's a lot of things that look the same that aren't the same. There's got to be a reason for it because it's symmetrical and they're both equal distance from the center. So putting together your answers, that's the answer. That's the correct answer. Okay, so that's 34. Now let's go over here. Let me shade this in. So this is 34. We're done with these guys. Now let's go to the blue. What percent is in there? And how do you know? Because I bet you a lot of you can do this. But how do you know? How much is in the blue and yellow? How much is in the blue and yellow? 95%. We know that, right? We know both of them together are 95%. It's written right here. What do we know about the blue? What do you know about the yellow? Makes up 68%. And what else do we know about the yellow? They're symmetrical, so they are the same size. Okay? What do we know about the blue? They got to be the same because it's symmetrical. So what size are each of them? 13.5%. Yep, 13.5%. Because if you add up 34 plus 34, you get 68. Well, the whole thing has to be 95, right? So you subtract 95 minus 68, and you get 27. Well, if the two blues are exactly the same, what's left over? 13 and a half and 13 and a half. Okay. All right, there's two other spots I want you to find. Not more than two, actually four, but they're both the same. The green and the purple. I want you to tell me what percent is in here, what percent is in here, and same thing over here. I'll give you a hint. The greens will be the same and the purples will be the same. For the green, 2.35, 2.35, 0.15%, 0.15% for the purple. All of those added together, if I add all the colors up, what would they equal? Not 100. 99.7. Yeah, 99.7, which is the same as here, right? The same as in here. Because what they're going to ask you, what we're going to do tomorrow is they're going to ask you questions. They're going to say, what percent of the data is 1 standard deviation and above? If you just had this guy, it would take you a while to do the pink and the red and that color out there, whatever color that is, right? But here, oh, 13.5, 2.35, 0.15, you add it up, you got it. Okay? You'll see when we do. First thing we're going to do tomorrow is that other paper. We're going to start on this other paper. We're going to talk a lot about female walruses. Female walruses. More than you want to know. Okay? The tables, don't lose that. Protect that with your life because you're only getting one. And that thing we're going to use all year long. So don't lose it. Put it somewhere safe. Don't fold it. Don't bend it. Just put it in your folder somewhere so that it stays safe. That's why I put it on thick paper. Okay.